Okay, with the completion of section 2.8, we are now moving into 3.1, chapter 3. All right, and it's looking like we're going to have a quiz over 2.7, 2.8, 3.1, and probably 3.2, probably on Tuesday of next week. So start being ready for that. Maybe Wednesday of next week, so we have a day to talk about it, and then we can do another section, review a little bit, and then we'll take that quiz. So here we go with this. Let's see, the very first section is we're going to work on how to define the system. We're going to have a system of equations, which is two or more, and we're going to find out where their answer is. And actually, you've been doing this for a long time. Anytime you comparison shop, you're doing this. We're looking for where two lines intersect. This is all that we're doing. So a solution of a system is a set of values or a pair that makes both of them true. Now, there may be some cases where we're not going to do all this stuff. We're not going to do a table for sure. Today we're going to work graphically, and then when we have some word problems, it almost always works out better if we can do those word problems algebraically than graphically, just because they don't work out to be very clean answers. But we're going to start off with graphically here today. We're going to put to use a lot of stuff that we've done in the past. So for this particular equation, we have two of them here, so we'll always have two. And we're talking about those two, and we want to make sure that we find where these two intersect. Now, I have to be very precise with this. So I'm going to use a straight edge or a ruler whenever I draw a line here today, just because I got to find this is exactly where the answer is. That line is where the answer is. So I have two equations here. Both these are in the slope-intercept form. So I'm going to take on the first one, and I'll add 3, put my dot, and then down 5, 1, 2, 3, 4, 5, and right 3. 1, 2, 3. Put a dot. And I'm going to see if I have on this little thing, I'm going to draw a line. And it's going to be nice and hopefully nice and straight. Line, there we go. And I don't connect those two, and that's not what I wanted to do, so I'm going to go back. I got to make sure I get this right. I want a line. There it is. There we go. And this line has got to be correct. And I'm going to make sure that I have this right. Draw this out a little bit further. So there it is. All right. Now what I need to do is I need to do the second one. So for the second one, I'm going to make it a little bit different. For the second one, I want this line to be red. So the first thing is I go down 3, put a dot, and then that's awfully wide. Up 1 and over 3. 1, 2, 3. I gotta change the width of my line here because that's just not good. Oop, I want to drag the whole thing. Let's see. Line. Okay, I'm going to stop messing around with this and call this good. So right here's my solution. That happens when the x was 3 and the y was -2. What that does is if I put those numbers in here and then do the math, I don't end up with the same answer. Both of them are going to work. So let's do the top one. -2 is equal to -5 thirds times 3 over 1 plus 3. Those cancel off. -2 is equal to -5 plus 3. -2 is -2. So it worked for this first one. Try the second one. So -2 is equal to 1/3 times 3 over 1 minus 3. -2 is equal to 1 minus 3. -2 is -2. It works for both. That's my answer. So what I'm really working on is I'm working on my graphing a line. Got to have a graph paper, got to have a straight edge for this. And then I go through and I come up with what this particular answer is because that's the intersection of those two lines. Now, obviously, a line can intersect. What happens if I have a line. What happens if I have two lines that are parallel? Like, let's say if I drew these two lines. So what I'm trying to get at is, I can have two lines that are parallel. How many times do they touch? Unfortunately, they don't. Then I could also have two lines that are exactly the same. And I'm off by just a hair, but those two lines don't. So I have three options. One, I have a nice ordered pair. Two, they swing and miss because they're parallel. Three, they're exactly the same. We're going to focus on the first one. This is what you see 90% of the time. So for this particular one, my y-intercept is 3. My y-intercept is 3. My slope is 4. 1, 2, 3. Oh, I'm off the page. So 1, 2, 3, 4 over 1 to the left. The reason I want to move left on that is because I was going down. So now I have this particular line graphed. I always want to extend these lines all the way through my graph paper because I never really know they really meet. Now the second line is going to be a little different because it's not in slope-intercept form. This is in standard form. So if I put a 0 in for the x, this goes away, so that means it's -2. So over 0 down 2, put a dot. Let's say I put a 0 in for the y. Okay, that's a goner. That's -2. -2, put a dot. Now I got 2 points. I can make a line. And I'm going to stay away from that fatty and just stay with this one. So there's those 2 points. Looks like I'm going to look like this. Okay, so now it comes down to where do those two lines intersect? Right there, at -1, -1. And that's my answer. This is what we're doing today. We're looking for those two intersection points. What about this one? Okay, weeks. This bottom one here, I'm looking at these and right away I see two lines that are in standard form. Okay, the top one, I really like that this number plays nice with this and this number plays nice with this. So that top one, if I put a 0 in for the x, -2 will go into 4, -2 times. So I can get that 0, -2, put a dot. And then if I put a 0 in for the y, that's just 4. I can do this one really quick and easy. There's my graph, and there's my points. Here is my line. I'm going to drag this down a little bit further. Here is my line. So 2, 2, 4, there we go. It's really important that you get these things, you get it right. The line's got to be right where you want them to do because this is how we're coming up with our answer. So that one's good. Now the second one's not as simple. The reason why I don't really like the second one, these two numbers don't play nice. It's only end up to be a fraction, so I don't like that. So I'm going to put this into slope-intercept form by subtracting 3x from both sides. Now I'm better, so I can go and put the dot here, go down 1, 2, 3 over 1, 1, 2, 3 over 1. Oh, that kind of gave away where I'm going to intersect. I'll draw my line. And I really did a bad one here. So I'm going to try to get that so I can drag the whole line over. Oops. That looks better. So that intersection point's right here at 2, -1. Special cases. Well, what happens if I have a case like this? Okay. Well, in this particular case, if I'm going to go graph this, and let's try to do that here. So let's see if I can work my magic with this. Let's go there. I need a border. Nope. I need a border. essentials, backgrounds. I need, where's that? I just saw it. There she be. Let's go with the medium. Okay, and let's split this page. Do a page display. Cool beans. And let's make it big. Okay, so I have this. So let's put this -4, 1, 2, 3, 4, dot, up 2 over 1. Let's draw my line. And there she be, there she be, there she be. Oop, I missed again, so I'm going to make it off all the way through. I didn't miss as much as I thought I would. There you go. There's that first one. And now the second one, I'm going to go up 3. 1, 2, 3, put a dot. And then 2 over 1, 2 over 1. I'm going to draw this line. I'm going to draw this line just like what I said I was going to do. Now this was 2, 1. And here's the problem. Notice those two lines are parallel. They miss. Okay, so this particular answer for this one would be no solution. Now, algebraically, this was a lot easier. You see how the slopes are the same, but the water slopes are different? That means they're just still in a miss. They're two lines that look very similar, but they miss. The second problem that I have here, and I'm going to try to give me another new page here. So excuse me for just a minute. I gotta get this stuff. Let's add one, and let's get another background. Adios, Mr. Miller. I'm teaching my lesson right now. That's okay. You too, Mr. Miller. Thank you. Okay, now for this one, I'm gonna go up 2, put a dot. I'm gonna do this one first. I typically do the one I think is easiest first. Down 1 over 2, down 1 over 2, down 1 over 2. I'm going to now graph my line. And there she be. There it is. Now let's do the second one. The second one's not quite as easy. It looks a little worse. Hey, but notice those numbers play nice. Let's do that way. Okay, this is in standard form. So if I put a 0 in for the x, the y is 2. So over 0, up 2, put a dot. And if I put a 0 in for the y, that's a 4. So, oh my gosh, they're the same line. All real numbers. Now, I really don't like problems like this because you know what? I want to find the answer. But those are special ones. Now, if I were to take this top equation and solve it for y, put it in slope-intercept form, divide everything now by 4, I'd have found out those two are the same thing. So if I'm algebraically somewhat easier to take care of these special cases, if I'm drafting these by hand, I might have to just discover it. So that's it. Today, what your assignment is then, sorry about that, is we have a worksheet for you to do. So you need to go ahead and go and do that worksheet. You may have to download some graph paper. I just don't have any of that available for you. So I would suggest you download some graph paper, probably go in 10 by 10 squares, and then you should be able to do these problems pretty quickly. All right, have yourself a good day.